A very good afternoon, dear students. Let us solve the next numerical. Determine the moment of inertia of the figure shown below considering the given axes. Okay, so the values, the axes that are given to us is x is given here and y is given over here. That makes the origin over here. Now what we have to do is we have to calculate the centroid using this particular coordinate axis and find out whether the centroid of this entire figure, does it coincide with the origin or does it lie somewhere else. So we will first do that. Let's first calculate the centroid. To calculate the centroid, what we had done, we will do exactly like the previous question. So we will take three individual figures, naming them as 1, 2 and 3. For these individual figures, we are going to mark the centroids. So the centroid will come at the intersection of the diagonals 1, 2 and 3. Let's name the coordinates from the x and y axes. Now if we notice that all the coordinates, that is centroid for the first figure, second figure and third figure, they lie on the y-axis. That simply means that there is no distance between the y-axis and the coordinates itself. That simply implies that individual x's of each diagram is going to be 0, and since that is true, as well as we can also see that the area on the left hand side is equal to area on the right hand side. So we can say that this entire figure is symmetrical about the y-axis. Since it is symmetrical about y-axis, therefore capital X directly comes out to be 0. Okay, this also implies, since the figure shows that all the coordinates are lying exactly at the center, therefore x1 is equal to x2 is equal to x3, and they all come out to be 0. This may not be the case always, but for this particular question it is. Okay, now let's find out what are the y coordinates. So for the first coordinate, that is over here, what we are going to do is we are going to take distance from the x-axis upward. So this coordinate distance will be y1, y2 and the x-axis are coinciding, therefore y2 is going to be equal to 0, and y3 on the other side will be the distance from here till the centroid here. Okay, so let's write it down over here. We have y2 as 0 just for our reference later. Okay, let's consider this table here. What we are going to do here is, as we did in centroid, similarly we are going to go step by step, take the different components of the I section, okay, and we are going to go ahead and find out the overall centroid. So let's go with shape number 1. So the shape number 1 is a horizontal rectangle. It has a dimension of 24 by 6. The second shape that we have is a vertical rectangle which has a dimension of 8 by 48. Then we go with the third rectangle, which is again a horizontal rectangle whose dimension is 48 by 6. Let's go ahead and calculate the areas. So we write the x first, that is 24 by 6, that comes out to be 144. We have taken all the dimensions in mm, therefore what we are going to get is mm square. The second we will take as 8 by 48, that value comes out to be 384 mm square. The third value is what we are going to take as 48 by 6, the value comes out to be 288. Now since the original, since we have already checked that the x components of each are 0, therefore we simply mention them as 0. We know that the y component y2 is 0, so we mention y2 as 0. Let's calculate y1 and y3. Now we know that the entire distance from the x-axis till the bottom of the top rectangle is 24 and the dimension of this rectangle is 6. So half of that we will consider for the CG. So 24 plus 3, that comes out to be 27. So we have y bar over here as 27. Similarly 24 and 3 is 27, but this is below the x-axis, therefore you are going to get a value of minus 27 here. Now if you notice the previous question that we had solved where we took about a centroid, at that particular time we had also taken another column known as area into x bar, which is the first moment of area along x. Here why we are not considering that is because we already know that capital X is 0. So we know that the centroid will have a x component as 0. Now let's take AY. We'll multiply the area into the y component and write it as AY. So this comes out to be 3,888. This comes out to be 0. And since this is a negative value, minus into plus gives you a negative sign over here. That is minus 777.6. Now we see the capital X of each figure and the small x of each figure, and what we are trying to do is we are trying to calculate capital X minus small x whole square. Now since both are 0 in each condition, therefore here every value comes out to be 0. Similarly for the y, we are going to consider the capital Y, for which we have to do the necessary calculations. So let's do the necessary calculations. Here we have to take summation AY bar and we have to take summation A. So summation A comes out to be 816 mm square, whereas summation AY bar comes out to be minus 3,888 mm cube. This is mm square. Now let's calculate capital Y. Capital Y is nothing but summation AY bar by summation A. So that is minus 3,888 divided by 816. The value comes out to be minus 4.765 mm. Now we have got the value of capital Y. Putting the value of capital Y into this equation, we have minus 4.765 minus 27 whole square. So if you want me to write it, I'll write it over here. So the calculation is going as minus 4.765 minus 27 whole square. This is what we are going to get as y minus y1 whole square. Similarly, y minus y3 whole square will be equal to minus 4.765 minus of the equation and minus of the coordinate itself. So negative into negative will be positive and you will get a value of plus 27 over here and squaring the whole term. Here we get the value which I am directly writing over here. So we have a direct value of 1009. Here we have the value of 494.4. Now we have to remember that our small y over here, that is y2, is 0. That does not mean that capital Y minus y comes out to be 0, since we already have a value of capital Y. Therefore, this particular value will be nothing but the square of this term, which comes out to be 22.7. Now what we have to do next is calculation of IGX and IGY. Now what is IGX and IGY? It is simply the centroidal moment of inertia about x and centroidal moment of inertia about y. These have definite formulas. So IGX is given by BD cube by 12 and IGY is given as the opposite, that is DB cube by 12. These are standard formulas. In this, what is B and what is D? Let us find out over here. Let's consider that you have a rectangle. In this, always the distance in the x direction is termed as B and the distance in the y direction is termed as D. So you get the equation as B D cube by 12. In the second case, you will take D once and we'll take the cube of B, but the distances remain the same. So let's calculate the distance using BD cube by 12 and DB cube by 12. So we get the values of the first rectangle considering B as 24, D as 6, BD cube by 12 comes out to be 432. Similarly, DB cube by 12. So in this case, D will be 24 and in the first case this is B and this is D. In the second case this will be B and this will be D. And you have to use the same equation and solve it all over again. With that you get a value of 6912. Here all these values will come in mm raised to power 4. How will this come? Is because your B is in mm and D is also in mm, but it is in cube, therefore that is mm cube into mm, that comes out to be mm raised to power 4. Let's calculate the other values. So this value comes out to be 73728, whereas this value will be 2048 after calculation. The next value we get over here is 864 and the next value here we get as 55296. How do we get these values? Considering B and D for the first case and D and B for the second case. Similarly, we calculate for all the entire rows. Now that we have calculated IGX and IGY, we have calculated capital X minus small x whole square, capital Y minus small y whole square. We also know the area. Now let's calculate the entire centroid value. So that is IXX. IXX is given by the equation IGX plus area into y square. Now we have to know that this particular y square that is there, we have already calculated and even squared. So we do not have to square this term again. We just have to take and replace this term in the equation. Now while we are noting down the equation, you have to see that this particular equation, that is IGX plus area into y square, has to be applied for each rectangle. So in this particular equation you are going to get 3 brackets. Each bracket is going to resemble one of the rows. So each row 1 bracket. Let's go ahead. So we have IGX, that is 432, plus the same row area is 144 into y square, you get it as 1009. This is 1009. Okay. So this entire thing is the first row. Now we add the second row because all the 3 rectangles are getting added. So we go IGX, that is 73728 plus area in the same line, that is 384 into y square, that is 22.7, plus we go with the third bracket, that is 864 plus area 288 into y square, that is 494.4. Totaling all the 3 brackets, we will get the summation that comes out to be IXX equal to 371,424 mm raised to power 4. This is the value of our Ixx. Similarly, let's calculate the value of Iyy, which is equal to Igy plus area into x square. Again, let's note that this x is already calculated over here, which shows us that all the terms are 0. Now, these 0 terms indicate that this portion over here, ax square, this portion over here will turn out to be 0. But that does not mean that the overall moment of inertia is 0. It simply means that this component for all the rectangles are turning out to be 0 in this case. Therefore, we just have to add a summation of Igy for all the 3 terms. So, considering Igy, this one, second one and the third one, let's write the values. So, that comes out to be 6912 plus 2048 plus 55296. So, the overall value comes out to be 64256 mm raised to power 4. Now, we have to note that it is not always the case. We have to check whether our areas are symmetrical about the y-axis or the x-axis, and if the individual areas too are equal. In that case, we will get capital X and capital Y both as 0. But in this case, what has happened is that since the area of the top rectangle is smaller as compared to the area of the lower rectangle, because of which our centroid actually does not lie at this particular point. It lies at a distance of minus 4.765. That means 4.765 mm below the existing x-axis which is given. Therefore, we can simply say that our CG of the entire figure lies somewhere at this point. So, this brings us to the end of the calculations for moment of inertia.